Hello everyone, and welcome to today's presentation on finding the maximum subarray sum using Kadane's algorithm. In this session, we'll discuss the maximum subarray sum problem and introduce Kadane's algorithm as an efficient solution. Our objectives today are to understand the problem statement, walk through Kadane's algorithm step by step, and analyze its efficiency compared to brute force approaches. Let's define the problem. Given an array of integers, the goal is to find the contiguous subarray that has the maximum sum. For example, consider the array -2, 1, -3, 4, -1, 2, 1, -5, 4. In this case, the maximum subarray is 4, -1, 2, 1, which sums to 6. Note that the array can include both positive and negative numbers, and the subarray must be contiguous. This is the challenge we are aiming to solve. Before we dive into Kadane's algorithm, let's briefly discuss the naive, brute force approach. In the brute force method, you check every possible subarray, which results in a time complexity of n squared, or worse. In contrast, Kadane's algorithm employs a dynamic programming approach that processes the array in a single pass, achieving a time complexity of n. On this slide, you'll see an animation comparing the exhaustive brute force method with the efficient, iterative process of Kadane's algorithm. Kadane's algorithm is based on a simple yet powerful idea. At each index of the array, compute the maximum subarray sum ending at that position, and update a global maximum if this value is greater than the current global maximum. The two main variables we use are current_sum, the maximum subarray sum ending at the current index. Max_sum, the overall maximum subarray sum encountered so far. The algorithm works by iterating through the array, updating these variables at each step. This simple idea is what makes Kadane's algorithm both efficient and easy to implement. To see this in action, we will go to Visual Studio Code and write the code for both the naive approach and Kadane's algorithm. I am first going to create a function called maxSubarraySumNaive. In this function, I am implementing a naive approach to find the maximum subarray sum. I define an outer loop that starts at each index of the array and an inner loop that sums the elements from the current starting index to the end of the array. With each new sum computed, I check whether it is greater than the maximum sum seen so far, updating the maximum accordingly. This approach examines every possible contiguous subarray, making its time complexity n squared, which is less efficient for large arrays. Next, I create a function called maxSubarraySumKadane. In this function, I implement Kadane's algorithm. I initialize two variables, max_current and max_global, to the first element of the array. Then, I iterate through the array starting from the second element. For each element, I update max_current by taking the maximum between the current element and the sum of max_current with that element. If max_current exceeds max_global, I update max_global accordingly. This method efficiently finds the maximum subarray sum in n time, making it much faster for larger datasets compared to the naive approach. In the main function, I define an example array that contains both positive and negative integers. I calculate the size of the array and then call both maxSubarraySumNaive and maxSubarraySumKadane functions to compute the maximum subarray sum. Finally, I print the results of both approaches. Benefit of Kadane's algorithm versus naive approach. Kadane's algorithm is significantly more efficient with a time complexity of n compared to the naive approach's n superscript 2. This efficiency makes Kadane's algorithm preferable when working with large arrays, as it computes the maximum subarray sum by scanning the array only once, rather than evaluating all possible subarrays. Let's run it and you will notice that both return 6. But the difference is its time complexity. We are done with the code. Now let's go back to presentation to summarize it. In summary, we defined the maximum subarray sum problem and explored the challenges it poses. Kadane's algorithm, a dynamic programming approach, efficiently finds the maximum subarray sum in n time using a single pass. We written code in C++ for both the approach's naive and Kadane's. Finally, we discussed complexity analysis. I now invite any questions or comments you might have on Kadane's algorithm. Thank you for your attention. On this note, I am stopping over here. See you in the next session.